Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Neural Networks. The AI's simple, yes, no, brain cells, how basic decision makers connect to form intelligence. Analogy: like individual light switches that turn on, off, but in a giant network to make complex decisions. Imagine building a super smart system, but only with simple, yes or no, light switches. That's essentially what a neural network is. It's a huge collection of these simple decision-making units, connected in a clever way, that allows AI to learn and solve complex problems, from recognizing faces to writing stories. As developers, we're building these interconnected switches to process information. At its heart, a neural network is made of neurons, sometimes called perceptrons. Think of a single neuron as one tiny light switch in our vast network. This switch takes in some information, inputs, processes it, and then decides whether to turn on, say yes, or stay off, say no. For a developer, you can imagine it as a tiny function or logic gate that takes several numbers as input and outputs. A single 0 or 1 based on an internal rule. Our neuron switch doesn't treat all incoming information equally. Each piece of information, an input, comes with an importance score called a weight. If you're deciding what to eat for dinner, hunger level might have a high weight, while color of your shirt has a low weight. The neuron multiplies each input by its weight, adding them all up to get a total score. From a developer's view, these weights are just numbers, variables, that we can adjust, making certain inputs more influential than others. After adding up all the weighted inputs, the neuron needs to make its final yes or no decision. This is where the activation function comes in. Think of it as a gatekeeper with a strict rule. If the total score is above X, a threshold, turn on, output yes, otherwise, stay off, output no. It's like a thermostat. If the temperature, total weighted input, goes above a certain point, the AC neuron turns on. This function transforms the raw sum into a clear decision. A single neuron is simple, but connect thousands, even millions, of them, and things get interesting. Neural networks are arranged in layers. Input layer, where our raw data enters, e.g., the individual pixel values of an image. Hidden layers, the thinking layers in between, where neurons make intermediate decisions based on the previous layer's outputs. These layers perform increasingly complex feature detection. Output layer, the final layer, giving us the network's answer. E.g., is this a cat? Or, what number is this? Single quote, it's like an assembly line, where each station, layer, processes the product before passing it to the next, building up complex understanding step by step. How do these switches know which weights and thresholds to use? They learn. We show the network lots of examples, e.g., pictures of cats and dogs, and tell it the correct answer. If the network makes a wrong decision, we gently adjust the weights and thresholds of its neurons, telling it, try again, but next time, give more importance to asterisk this input. This trial and error process, called training, allows the network to gradually become very accurate, much like practicing a skill. By combining millions of these simple, yes, no, decision switches and training them with vast amounts of data, neural networks can perform incredible feats. They power everything from voice assistants and recommendation systems to self-driving cars and medical diagnosis tools. The true magic for a developer is understanding that this immense complexity and intelligence emerges not from a single brilliant line of code, but from countless simple components learning to work together to spot patterns no human could explicitly define. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.